All right. So you guys should have just like a pencil and some paper. We're going to take some notes on factoring. So let me screen share here.
Go ahead, get the pencil ready, buddy.
Jeb, mute yourself. Come on.
All right. Can you guys see that okay?
Yes, ma'am.
Okay. Cool. So we've been doing some algebra bootcamp stuff, mainly to just prepare you for what you'll see either in college. Well, yeah, in college next year. If you're a junior, you probably won't be taking like a high level math next year, if any. So I just want to get you prepared for what you're going to be seeing in college and what the students that I taught at in college when I taught at a community college for Rowan, what they struggled with the most. So factoring is a big thing, and we've talked about it a lot this year. Okay, so the main part of factoring, the first thing you want to look at is the greatest common factor. So we'll see how this works, me writing on the screen. Can you guys see that okay? I just wrote EX.
Yes, we can see that, okay.
Okay, awesome, thank you. I know I asked you to mute and then I'm
I
asking
can.
for your response. Sorry, I'm being like, all right. Okay, let's go through an example.
Good, Jackson.
Aaron, nukes.
Okay. All right, so let's take a look at these two examples here. They'll start off pretty simple, but the idea behind his greatest common factor is that that's the first thing you always want to look for when you're asked to factor anything, or even when you're asked to solve something and it's set to 0. So we want to look for the greatest common factor between 16 and 4, which is going to be 4. And then we want to look for the greatest common factor between p to the 4th and p cubed, which is just the smaller exponent, so p cubed. So 4p cubed is our GCF. And then essentially factoring, right, is just reverse multiplication. So we want to basically see, okay, what did we distribute 4p cubed to in order to get back to both this term and this term? So 4p cubed times what will give us 16p to the 4th. 4 times 4 gives us 16. And p to the cubed times just p or p to the 1st gets us back to p to the 4th. So if we were to multiply these two together, we get back to our original 16p to the 4th. Plus, same idea for what do we multiply this 4p cubed by to get back to 4p cubed, which is just 1. So you'll note that you have the same amount of terms inside your parentheses that you started with. Okay, for our next example, we want to look and see what value is going to fit into 63 and 35. And that value is 7. And then x to the what, right? So it's going to be the smaller value, so x to the 5th. So 7 times what will give us 63? That's 9. And then x to the 5th times what will give us x to the 12th? That's x to the 7th. And that's because properties of exponents tell us that when we're multiplying two exponents with the same base, we add the exponents. So x to the 5th times x to the 7th is x to the 12th. And then our next term is going to be minus just 5. So if you were to distribute through here, you'd get back to the original. So that's all I wanted to talk about with GCF. Next, I want to move on to difference of squares. All right, so difference of squares is when we have a binomial. So it's just a binomial, which means we have two terms, and they both have to be perfect squares. And we have to be taking a difference, which means we have to be subtracting. So our first example will have 9x squared minus 16y squared. All right, this is a difference of squares because we're taking a difference, right? This term is a perfect square. The square root of it would be 3x. This term is also a perfect square. The square root would be 4y. And just in general, if you want to write difference of squares, it's when we have a squared minus b squared, and it factors into a plus b, a minus b. So what are like our a and our b here? Well, our a value would be the square root of this term. Our b value is the square root of this term. So we already determined that our first term in each is going to be 3x. And then our b value, the square root of this term, is 4y. If you were to multiply that out, again, factoring is just reverse multiplication. You would take 3x times 3x and get 9x squared. So this is just a quick check here to see why this works, right? We'd have to like FOIL it. So we do this times this, 3x times 3x, get 9x squared. We do 3x times negative 4y and get negative 12xy. Then we'd multiply through by the 4y and get plus 12xy and then minus 16y squared. The middle two terms, the o and the I of FOIL, will end up canceling out. So you're just left with your original. So that's why one has to be plus and one has to be minus. So the inside terms will cancel. All right, let's do another one.
Mr. Maj,
Uh-huh.
Don is waiting for you to let him in.
Oh, he is. Thank you for letting me know. Okay.
Curry.
Let's see. How do I let him in? There we go. Hi, Christian. All right, I'm gonna go back to the screen share real quick. You guys doing okay with it?
Yes, ma'am.
Yeah.
Okay. I know it's kind of boring. All right. Okay, let's do one more example with difference of squares. I'm gonna have you guys just try this one on your own. Let's do 16m to the 6th minus 25. Go ahead and try that one, see what you get. Okay, so the first term is in fact a perfect square. 6 is not a perfect square, but m to the 6th is because of properties of exponents. So the square root of this term is going to be 4m to the 3rd. And that's because when we multiply m to the, 4m to the 3rd times itself, we'll get 16, obviously. But then m to the 3rd times m to the 3rd is m to the 6th. So really, if you have an even exponent, that means that that term there, like m to the 6th, m to the 8th, m to the 12th, whatever, would be a perfect square. And then 25 is 2. So we'll have plus 5 and minus 5.
So for the, like, say if it's like 16 under the 12, would that be the person? Would that be 6 or what?
Yeah, 4m to the 6th.
Okay.
Yeah.
Yeah.
So just half.
Okay.
And that works here too, right? Like x squared, its square root's just x to the first. Just
Yes,
half
ma'am.
of 2. Cool. So I'm not spending a ton of time on these first 2 slides, but really the idea behind GCF is that anytime you're asked to factor, that should always be step 1, is just to see if you have a GCF. And then whatever remains might be able to be broken down even more, right? Like if we look at this example here, when we broke this down, what was left? Well, we had a binomial left. Is it a difference of squares? No. 5's not a perfect square. X to the 7th is not a perfect square. 7's odd. So we couldn't keep going here. But that's kind of the idea. This would always be step 1. Then if you're left with some binomial, which means 2 terms, right? Bi is 2. Then it could potentially be a difference of squares. If it is, you want to keep going, like these 2 examples. Okay, the stuff that I feel like we have the hardest time with is factoring trinomials, quadratic trinomials. So trinomials obviously have 3 terms. And quadratic just means that they're x squared is the first term, right? So a quadratic trinomial just looks like this. Okay, where a, b, and c are the coefficients. So we have the squared term, the quadratic term rather. Okay. There we go. And then this is called the linear term, just because it's x to the first. And then this is just our constant. So there's like 2 types, right? There's the easier type to factor where a is just 1. So you don't really even have an a value. It's just x squared. And so that's like the easier type of trinomial that we've worked with more this year. So we'll do a couple of these. I'm going to show you a few methods. So our first example of n squared minus 11n plus 10. So again, we're dealing where a is just 1. And in this case, a is 1, right? It's 1n squared. So when a is 1, you have a much easier time factoring. I call this like the easy method. You basically just want to find 2 numbers, right, that'll multiply to give you c, or 10, that will add up to b, negative 11. And so we know that we're going to have 2 binomials. And essentially, again, we're backwards multiplying, right? We are backwards like foiling, which is just multiplication. So in our first spots here, we know that an n goes here and an n goes here. That's because we have to multiply first times first to get n squared. We're just working backwards. Then our lasts, the numbers that go here and here, have to multiply to give us 10. Well, we know that there's a few options to give us 10, right? Could have 5 and 2, negative 5 and negative 2. I'll write them out. We could have, 5 and 2. We could, of course, have them both be negative to multiply to positive 10. We could have 10 and 1, or we could have negative 10 and negative 1. So these are all possibilities that could go there, 4 different possibilities that could go here and here to multiply to 10. But they also have to work out for the middle term to give us negative 11n. So these add up to 7n. This adds to negative 7n. This would add to 11n, and this would add to what we want, negative 11n. So if we use minus 10 and minus 1, it works out. If you were to multiply this through to check, and we multiplied it through, we would get what we needed. And that's why those middle terms will add to our b value. All right, I'm going to show you guys kind of a cool method. Did anybody learn the box method in like algebra 2?
Oh,
I remember that, but I don't know if I know how to do it.
Okay, I'm going to show it with this example because once we get to the harder trinomials, it's a lot easier. I'll keep that. Okay. All right, so let's try like the box method, see if it works, if you like it, because it works for any quadratic trinomial. All right, so you're going to draw a box, and it's going to have 4 parts in it, like a window. And then what goes in there? Your first term goes in the first section, and your last term goes in the last part. And if it was negative, you'd have to include that. All right, I'm going to put the 1 there. So essentially our thought process is the same, right? What's going to go here and here? Well, you have to multiply A times C. See, before I just told you C, 2 numbers that multiply to 10. That's because A was 1. In order for this to work, if A is whatever, A might not be 1. So we have to remember to multiply by it. We'll see that in the next example. So if we multiply A times C, 1 times 10, we want 2 numbers that'll multiply to that, which is 10. That'll add to negative 11. So the thought process is still the same. Our winners are negative 10 and negative 1. So that's what goes in these 2 here. It does not matter what order you put them in. And then we have to just put an n after it. Again, because those 2 things will add up to become a negative 11n, the middle term. Okay, from this point, we use GCF factoring. So we look down the first column here. What's the greatest common factor between n squared and minus 1n? It would just be n. That's what we could like pull out of these 2 terms, essentially. Then we do the same thing here in the next column. What could we take out of negative 10n and 10? Well, we want to take out a 10, but we want to take out a negative 10 because the first term is negative. Then we do the same thing going across the rows. What's the GCF here? The GCF here would be n. It would be positive because this first part's positive. And then we do the same thing for the second row. The GCF between these 2 terms would be negative 1 since the first term's negative. And then those are our 2 parentheses. So our answer would be n minus 10, n minus 1. So that's the box method. It's a little bit of overkill when A is already 1, but it works out really well when A is greater than 1, which is what we're going to go into next. All right, so I have 2 examples here. And we'll do the box method for them. Okay, so the first thing we want to do is A times C. So we want 2 numbers that are going to multiply to give us negative 15. A times C. And that are going to add to give us negative 2. So this is my symbol for multiplying to negative 15. And then adding to give us negative 2, the middle value. So we need to think about what 2 numbers will do that. Well, numbers that are going to multiply to give us a negative, one has to be positive, one has to be negative. And the values that will do that are going to be 3 and negative 5. they will both multiply to negative 15 and add to the negative 2 that we wanted. So those are like our winners. So then we draw the box. Our first term goes in the first, and our last term goes in last. And then these values right here go in the remaining spots with x's after them, since they have to add up to negative 2x. So again, the order doesn't matter that you put them in. And then we just GCF. So going down our first column here, 3 and 5 don't have anything in common except 1, but we can take out an x, and it's going to be positive because the first term's positive. Going down this column here, we only have a 1 in common. And it's positive, so I'll write it as +1. Looking across the row, these have a 3x in common. That's their GCF. And looking across this row, we want to take out a -5 because the first term is negative. And those are our answers. So factoring out, it'll be x + 1 and then 3x - 5. If you were to FOIL this out to check, we'd have 3x squared minus 5x plus 3x. We force that to work. And then -5. Okay, I'm gonna give you guys, go ahead and write down example 2. I'm gonna go back to being able to like see you in the gallery view on Zoom. So write down number 2, and then we can work through it together. All right, try it, ask questions if you have any, just work through it. We're all still alive, we're okay.
Of course.
It wasn't that bad.
Okay, good.
Fellas, it's looking like a great year, you know.
I feel bad for you seniors. Like, this is a
It's
weird way
horrible,
to
man.
end your,
Killing me.
yeah.
Head up,
Mhm.
Who said
brother.
that?
Josiah.
Josiah.
Aw. Have you guys heard anything about graduation at all?
He said we're gonna have it, but I don't know how.
Yeah.
Curry.
Steph,
He's on mute, I think. Curry.
what?
Who's Ron Quita?
That's Coleman.
Is your mom's name Ron Quita, or you just?
Who? Who?
Like, why is that your name?
Ron Quita.
Oh.
What happened?
Hey. Hey.
All right, so we should be getting 2 numbers. We want to figure out 2 numbers that multiply to -18.
-18.
And that add up to
3.
3.
3. Awesome. So is anybody, are we using the box method, or is anybody
I
just
like the
like
box.
guessing?
I like the box.
You like the box method?
Yeah, I think it like organizes your work.
Yeah, I like it too.
Yeah.
Gordon.
Gordon, stop with the streak pictures.
Get off your phone, brother.
I text something, so
A glacier.
don't worry about me.
Goydam, smell.
Rolo. You smell actually. Take a shower, buddy.
Goydam, underwear in the mirror.
All right, is anybody able to like screen
Lord.
share with a whiteboard?
I
Do
don't
you guys
know.
have that ability since it's
We have the ability
We
to
can share a screen.
but
I don't
doesn't
know.
say whiteboard? I'm gonna try that on here.
oh
How's that? You guys see like a white?
It's white.
Yeah.
yeah, I do. I thought
Yeah,
my
it looks
Okay.
amazing.
Huh, cool. Maybe I can use this too.
Looks like Thank Donnie on cookie.
There we go. It's easier to write when my iPad's down. Okay.
Saliva.
All right, so we wanted two numbers that multiplied to -18 that added to 3. What do we get for those values?
X plus 3, 2x minus. Oh, sorry. I'm going too
I got 6 and -3.
30. Yeah.
Okay. All right, so that's what just goes in the two sections of the box. That's not necessarily a part of our final answer, right? So,
No.
all right, what's gonna go in here?
2x squared.
2x squared and -9.
2x squared, -9.
Okay. And then these guys, 6x and -3x, go in the corners. Okay. We want to take out GCF, right? What do we get for the GCF here of 2x squared and -3x?
X.
Just
X.
x.
Yes.
How about the GCF here?
3.
Cool, and it's positive, so I'll just put it as a plus. And then how about going across here?
2x.
Right there.
Great. And then how about across here?
-3.
-3.
Cool. Awesome. Okay. So I'm kind of struggling because the Blackboard is still down for like submitting stuff, unfortunately. So it's hard to like get a bunch of submissions via email with like all my students. So what I'm gonna do is give you guys one more to work through today. And then once you're done with it, and maybe you can just like show me on the camera that you've like done it.
Okay.
I don't know. Then we can be good. Is anybody not able to do that? I think I was able to see everyone. I don't know if I saw Michael A or Josiah. Not calling you out. It's okay if you can't have the camera. Are you guys
No,
able to
got
do
a
that?
camera.
I'm scared.
I don't have
I'm
a
scared.
shirt on. That's why. So I was just
Oh,
cooling.
okay. Why don't you
Don't-
put that on? Haven't you
He's
guys heard
just
that
cooling.
comfort is the enemy of creativity?
You just
So
chilling.
you gotta be uncomfortable to be creative.
That's right.
Good, Alexa. Love it.
All right, I'm gonna give you guys one more.
I just want to play 2K.
Add your player base.
What's 2K?
Jackson, are we still playing 2K?
NBA.
The basketball.
Oh, NBA.
Jackson, are we still gonna play 2K?
Yeah, bro.
Where's Yell at?
He's not in here.
Mm-mm.
New Jersey.
Okay. I'm gonna give you guys one to work on here.
Shelly.
Hey, Donnie.
Shelly Cray.
There's my name is Shelly, Mom.
Aglushies.
All right, there's your last
Yeah.
one for today. Let's think of it as like our pass out of class. So just show me what you end up getting on your
Miss
paper.
Domage, this is gonna be insanely easy.
Good.
Bro.
The idea is for a nice end to the year, right?
We.
Right.
I think not last 5. That might be.
Goydum, you smell.
Shut up.
Mood.
Boy, I'm about to beat you in my team.
Guys, virtual bullying is still bullying.
Exactly.
Goydum, stop crying.
Not crying, bro. I don't even care what you said. So weird.
Then why'd you FaceTime me last night?
I don't even have your number. And if I did, I'd probably report it.
This one's kind of harder to find, though.
Goydum, turn your phone off, bro.
Not my phone.
The Galaxy Tab number.
Not my phone.
His dad got a pickup to do. Leave him alone.
What the hell?
You're funny.
Curry, what'd you get? Hey, how are you doing on this one? Has anyone found the 2 points yet?
No, I haven't found them.
Yeah.
No.
Add and
So 5, 18. Oh,
It'd be 15 and -3.
Yeah, 15.
no,
negative
-15, -3. It's add
Negative 15, -3.
Are you sure, bro?
Yeah.
How do you know it?
It is. Donnie, please be quiet.
Yeah, -3, bro.
Cool. So we wanted two numbers that multiplied to 45, right? 5 times 9.
Let me see if I can shut it down.
That add to -18. Yeah. So in this case, they both have to be negative since they need to multiply to a positive, but add to a negative.
Do you want us to share our work right when we get it done, or do you want to just like wait for others to finish?
Yeah, let's just wait a sec.
All right.
Give you guys a few more minutes here.
Yeah.
If you guys need assistance, let me know.
Good. Nukes.
Okay, I'm gonna turn your mics on, guys. I'm gonna ask you questions. Just like call you out a little bit at the end, okay?
Okay.
You ready? All right, turn your mics on. Okay, I'm just gonna go down here. Michael, what's our first step here?
Figure out what the first and last ones multiply to.
Okay, which is?
45.
So we need numbers that multiply to 45 that add up to what?
-18.
Awesome. And what did you find those two numbers to be?
-15 and -3.
Thank you. All right, Jackson, what'd you do next?
Then I created the box.
Okay, and tell me one thing that you put in it.
I started off with just putting 5x squared at the top left.
Cool. Jeb, go ahead and fill in 2 other spots. Let me know.
For the top right, I put negative 15x. And then below 5x squared, I put negative 3x.
All right, Brendan, what goes in the last spot?
9.
Awesome. And then what's the GCF here going down?
Where?
Down the first column with 5x squared and minus 3x.
Is that the one that's going to be on the top?
Yes, what's going to go here?
X.
X. Thank you, sir. All right, Jacob. What's the GCF going down this column here of negative 15x and 9?
Negative 3.
Cool. Why do you know it has to be negative?
Because 15 is negative.
Cool.
Yes.
All right, Christian. Going across this row here, what's the GCF of 5x squared and minus 15x?
5x.
And then Matthew, what's the GCF going across here of minus 3x and 9?
Negative 3.
Cool.
Good.
Ben, what's our final answer going to be?
X minus 3 times 5x minus 3.
Great. And then Josiah, how can we know that we got the right answer?
Because it checks out with the box.
Okay, definitely. What's something mathematically that we could do in order to check that it gets us back to here?
Boil it.
Yeah, we could just multiply it through for sure. All right, nice job, guys. So what we're going to do on Wednesday is kind of like a virtual board work. I'm going to send out something through email, and then we're going to work on it on Wednesday together. And then I'll give you your assignment that's due on Friday. And that'll be it for this week. Cool?
Love you.
Cool.
All right. Any
Like the
questions?
AirPods.
Thanks.
See ya.
All right. See you guys. Take care.
Bye.
Jeb,